What we're going to look at today is gravitational potential energy and kinetic energy. I'm going to split this into two shorter videos with some calculations at the end of each video. So we look down here, what we're looking at is this idea that objects that move to a greater height have more gravitational potential energy. We're going to learn that moving objects have got kinetic energy, and we're going to look at this idea of the relationship, okay, that shows that change in kinetic or gravitational potential energy. So you're going to be needing to remember some formula for gravitational potential energy, which is the one we're going to do first, and then in the second video we're going to look at the formula to calculate kinetic energy. We're also going to look at where it comes from. And what we want you to do now is, you've got a copy of this PowerPoint that I'm using at the moment. What I'd like you to do is just pause it, this video, and use on your PowerPoint, match up those scientific terms with their meaning. So, if we're looking at this one then, gravitational potential energy is the energy an object gains when it's lifted to a greater height. Kinetic energy is the energy a moving object has. Velocity is the speed of an object in a direction measured in meters per second. Mass is the amount of matter something is made up of. Height is the distance an object is above the ground measured in meters. Gravitational field strength is the force of gravity acting on an object measured in newtons per kilogram. And the joule is a unit of energy. Hopefully you got all those right, because we're going to be using those keywords throughout today's lesson. So here we go, there's our objectives again. And the first thing we're going to need to do is we're going to look at gravitational potential energy. This is gravitational potential energy. I'd like you to make a note of the title, gravitational potential energy, which we're going to call GPE, because it's a bit less of a mouthful than this for the rest of the lesson. What we can see here is that the change in GPE is equal to mass times gravity times change in height. In other words, the change, delta GPE equals mass times gravity times height. So, starting to wonder where that's coming from. So, what we've got then is this idea that work done is equal to force times distance. In another lesson, we looked at somebody climbing some stairs. And if we knew their mass, let's say 75 kilograms, then what we could do is, if we knew the height to which they'd moved, our distance here, then we could work out the work done. And what we would do is well, we need force, so we would take weight, which is equal to our force, which is equal to mass times gravity, which in this case is 75 times 9.8. And that will give me force, which in this case is 75 times 9.8, 735 newtons. And then we would multiply that by the distance. So we've got 735 times the distance. So 735 times the distance, which let's say is 10 meters. So the change in energy is 7,350 joules. Now, we've just said that GPE, gravitational potential energy, is equal to mass times gravity times height. Now, this comes off this idea that work done, which is actually the energy transferred, is equal to force times distance. So this is distance in the line of action of the force. In our case here, distance is the height. So this changes to height. Now, what we're doing when we're talking about gravitational potential energy is we're talking about lifting an object. And if we take an object and lift it, what we are doing is we are doing work against a gravitational field, G. So we are working against it. So we take our mass and we lift it. So that means we work against the gravitational field. So that gives us mass times gravity times height, where our mass times gravity are our force, which is our weight, the force required to move it through the gravitational field, times the distance, okay, that we move it through, which is S, or the displacement, if you like. So now you should hopefully be able to work with that, and you should be able to solve these questions. Now, I'm just going to do question number 1 for you. So hopefully okay, I don't want to close that, share screen, so we'll move to there. I'm going to just minimize that. I'm going to share a new screen. Might be able to do this, I don't know, I've never done it before. So I'm going to share a new screen. It seems like the visualizers turned itself off. Okay, so hopefully, there we go. Screen. I'm not so sure whether I can do this, but we'll just work. So we've got our question here. So minimize a bit more. Okay, let me just do it here. So question number 1. So what we've got then is we've got to calculate the energy gained by a 76 kilogram man. So I'm using bug FIFA. What we can do is we can box what we need to find out. So we're going to calculate the energy. There we go. And I can underline what we've got here. And we can write these down. So we've got energy, finding out. Don't know what energy is. I do know the mass, 76 kilograms. And I know it's taken up in an escalator 3.5 meters. Now I'm told over here that G is equal to 9.8. That's newtons per kilogram. So quite simply, writing out my formula, I've got GPE is equal to mass times gravity times height. I can now slot my numbers in, 76 times 9.8 times 3.5, and that is equal to 76 times 9.8 times 3.5. So a change in energy of 269 6.8 is equal to 2607 joules. Okay, so that's just change in energy. So what I'd like you to do now is just pause the video and have a crack at these questions. Oops. Stop. So hopefully you will have done those by now. If you move on, you'll find that the answers are on the next sheet. Now, I'd like to finish this off with this segment. So you've got this in your PowerPoint, you can print it off, or you could do the calculations in your book and write them in. What you need to do is you need to work out the total energy that your roller coaster carriage has at the top. Now, as you can see there, the height in meters is 100. You can take gravity as being 10 meters per second squared, or 10 newtons per kilogram, and the mass of the cars and riders is 5,000 kilograms. And what you need to do is calculate the GPE of your carriage at each point on the roller coaster. I need to draw in your own roller coaster design. Okay, thank you.